Hello everybody, welcome to Cranky Calculus. I'm going to go over a practice test I have here for integration. You can use this as an integration review. As I'm doing this, do not forget to like and do not forget to subscribe, and also go into the description, download this so that you have it, work on it, and make sure you're watching this video so that we can make more of these. So first up, I'm going to have some multiple choice in here, some free response. So first is our free response, which has mostly to do with integration, but it's got some stuff outside of that too, which is really good for us to sharpen up on in terms of calculus skills. So we have a graph right here. This is f prime, the derivative, which is twice differentiable function f, on a closed interval from 0 to 8. So I just know this graph's from 0 to 8. It gives me some horizontal tangent line, just so I know that at 1, 3, and 5, areas of the regions are given. And the function is defined for all real numbers and satisfies that f of 1 is equal to -6. So I'm going to go ahead right now and find the value of f of 8. In order to find f of 8 with the values that I'm given, is I want to use the fundamental theorem of calculus. Because I have f of 1, I want f of 8, I can rewrite this as the integral from 1 to 8 of f prime of x dx, and that's going to equal f of 8 minus f of 1. Now, as I'm looking at this area from 1 to 8, I have the area right here that I'm circling in purple, right there, and right there. Now, please take note that anything that's below the x-axis is going to give us a negative value. So the integral from 1 to 8 is going to be 6 minus 3 plus 7, and that's going to equal f of 8, which I do not have, but that's what I want, minus -6. And then from here, we're just going to use some basic algebra skills here. So we're going to get 10 equals f of 8 plus 6. So f of 8 is going to equal 4. Next up, for part B, we're going to find all values in the open interval from 0 to 8, in which f has a local minimum, and we're going to justify our answer. So as I'm looking at this, I can go ahead and make a sign chart, and I'm going to do that right here on part B. So we're going to go from 0 to 8. And we're going to have critical points whenever f prime is equal to 0. That's going to happen here at 1. It's going to happen again here at 1, 2, 3, 4, 5, and 6. Okay? So f prime here, this is f prime. We're positive from 0 to 1. We are positive from 1 to 4. We're negative from 4 to 6, and we're positive from 6 to 8. I draw these little arrows to kind of show me. And it looks like that we have a local minimum only going on at 6. So we're going to have a local min at x equals 6. And since I only have f prime, I can only talk about f prime. So because f prime is changes from negative to positive. All right, for the next section here, I'm going to determine the absolute minimum value, which means I need to use the candidates test. I'm going to use what I did from part A and part B. I'm going to combine that together here. It might be a little bit of work, but we'll get through it together. I'm going to use the part B part to get my critical points, and then I'm going to evaluate those using the part A method. So I have critical points here I'm looking at my sign chart right here. I have critical points here at 1, 4, and 6. I'm not going to consider all of them. Since I want the absolute min, I'm only going to consider local mins. So I only care about endpoints and local min. So as I'm doing this problem, I'm going to consider 0, I'm going to consider 6, I'm going to consider 8. Okay? So x equals 1 and 4. Right, x equals 4. X equals 1 and x equals 4 cannot be absolute mins because they are neither endpoints or local mins. Okay, so I talked about them. I'm good to go. So now to find these values, you need to f of 0. So I'm going to go ahead and do this FTC right over here. I'm going to go from integrate from 0 to 1 of f prime of x dx, and that's going to equal f of 1 minus f of 0. Now, I do have the value for f of 1. F of 1 is negative 6, so I'm going to substitute that in. So I'm going to get negative 6 right here, minus f of 0. And the integral from 0 to 1, it says that the area is 2, so I'm going to put a 2 right there. So if I add f of 0 to one side, subtracting the other, I'm going to get f of 0 to equal negative 8. So this is going to be negative 8. Now for my other endpoint for 8, I already found that value as 4. So all I have left is to find the value for 6. Okay, kind of ran out of room here. So I'm going to squeeze it on over here. If you do not mind, I'm going to do the value of the integral from, integral from 1 to 6. I'm going to do 1 just because I have that value. 1 to 6 of f prime of x dx, which is going to equal f of 6 minus f of 1. So the integral from 1 to 6, I need to go back up to my prompt here. From 1 to 6 is going to give me 6 minus 3. So 6 minus 3 is 3, and that's going to equal f of 6 minus f of 1, which we said before was negative 6. So it's going to give me f of 6 is negative 3. So I'm going to put my answer here. Actually, I'll keep it in green. So I'm going to keep my answer here as the absolute min. What's just the value? So the min is negative 8. Okay, and I can do this because I did the candidates test. I'm considering these endpoints because of f prime. So real quick, I will just say that f prime is equal to 0 at x equals 1, 4, and 6. And that's why I did consider this stuff. It's not really boxing my answer. I'm just kind of letting you know that that's there. Okay, so that's a tough one to use lots of integration. Actually, lots of stuff that we've learned so far throughout the year for that one. Part D, this one's not as bad. What open interval contained on 0 to 8 is the graph of both concave down and decreasing. So this is looking for the graph of f. Since I have f prime, I care about when f prime is negative, which is going to be increasing. So I'm going to have f prime is positive. So I'm looking for f prime is positive. I'm looking for f prime is decreasing. So when is f prime positive and decreasing? You can look at that right here. Well, I'm positive almost everywhere except for from 5 to 6, or this is 4 to 6. It's 4 to 6. But I'm going to be positive and decreasing from here from 0 until 1, and then from 3 until 4. So f is concave down and increasing from 0 to 1, and from, I already forgot, so I'm going to go scroll back up here, and from 3 to 4. Because f prime is positive and decreasing. I know I put that information up above, but I want to go in the format of answer because reason. Our last part here, we got a function g is defined by g of x equals f of x all cubed. If f of 3 is equal to negative 5 halves, find the slope of the line tangent to the graph of g at x equals 3. So in order to find the slope tangent of g, I want to find out what g prime is. So really, I'm looking for y minus y1 equals slope x minus x1. For a problem that we have here, we're going to go y1 is going to be equal to negative 5 halves, x1 is equal to 3, and the slope is going to be g prime of 3. So I need to find out what that g prime of 3 is. In order to do that, I'm going to go ahead and take this derivative. This is going to be some chain rule here. So g prime of x is going to equal, the derivative of the outside is going to be 3 times f of x squared times the derivative of the inside, which is going to be f prime of x. So if I'm trying to find slope, that's g prime of 3. We're going to substitute a 3 into here. We're going to get 3 times f of 3 squared times f prime of 3. It's going to give me 3 times, and I have f of 3. They said that that is going to be negative 5 halves squared times f prime of 3. So f prime of 3 is going to give me the value of 4 right here, because again, we have the graph of f prime. So this is going to be times 4. Oh, this will end up being nice. We're going to get 3 times 25 fourths times 4. We're going to end up with a slope of 75. So now if I just plug everything in here, to actually it just wants the slope. It doesn't even want the tangent form. I was doing too much. So the slope of g at x equals 3 is 75. On to the multiple choice section here, we do have this first integral of x squared root x plus 1 dx. And how do we integrate this? Well, first off, there is no formula that matches this, so we're required to use U-sub. So I always tell my students, pick the innermost function for the U-sub. So we're going to let u, this in purple, u equals x plus 1. But the problem is when you do this, you're going to end up with your du is going to equal your dx, and you're still stuck with an x squared. So what we're going to do is we're going to do something called algebraic sub, and we're going to manipulate our u so that we can actually substitute out that x squared. So I do know that x is equal to u minus 1, so x squared is u minus 1 all squared. So now I can rewrite this as integral of u minus 1, oh, if I can write better, u minus 1 all squared root u du. And then when I integrate this in terms of u, I'm going to substitute the x plus 1 back in and call it a day. I'm going to expand this before I integrate because I can't integrate it as written. So I'm going to rewrite this as u squared minus 2u plus 1, and we're going to multiply this by root u. So this is going to give me an integral of u to the 5 halves minus 2u to the 3 halves plus, really it's just u to the 1 half. du, because root u is equivalent to u to the negative 1, or root u is equivalent to u to the 1 half. Now I'm ready to integrate here, so I'm going to get u to the 7 halves multiplied by that reciprocal, 2 sevenths, minus 2 times, this is u to the 5 halves, multiply that by reciprocal, and then plus, this is u to the 3 halves, multiply that by that reciprocal, plus c. And at this point, I'm not going to finish this problem because all I have to do is substitute in these u's, and I can go ahead and see that a is going to match up here because I have the 2 sevenths, and then instead of u, it's x plus 1 to the 7 halves, minus this middle term gives me 4 fifths, x plus 1 to the 5 halves, plus 2 thirds, x plus 1 to the 3 halves. So it's clearly a. Moving on to the next one, what is the average value? Average value, the part of the graph of f of x equals x cubed 2 minus x. So first off, we need to figure out what the heck part of this is in the first quadrant. So in order to do that, I'm going to, actually, I know how to sketch this. Hopefully you do too. It has zeros at 0 and 2. Okay. This is going to have negative n behavior, so and we're going to cut through 2. And then we're going to change concavity here as we go through here. So this is what f of x looks like. So all I'm going to do is just, I'm going to go ahead and integrate between 0 and 2 here, and we're going to find that average value. So again, I set f of x equal to 0. This is going to happen at x equals 0 and 2. You shouldn't have a problem with that. Sketching it really helps to know what everything looks like. So once I'm here, I'm actually going to rewrite f of x as 2x cubed minus x to the 4th, which is a downward even degree function. That's another way we can know how to graph this, is it's a downward even degree function. So I'm going to have my bounds here from 0 to 2 of f of x, which is 2x to the 3rd minus x to the 4th dx. Since I'm finding the average value, I have to divide by the difference of the bound, so it's 1 over 2 minus 0. It's going to give me a 1 half. So I'm going to end up with 1 half. I'm going to integrate this. I'm going to end up with, I got 1 half x to the 4th minus 1/5 x to the 5th. Substituting my top value, I'm going to get 1 half times 1/2 times 2 to the 4th minus 1/5 times 2 to the 5th minus, and then everything else is zeros out, so minus 0. So who really cares about that? Everything's going to zero out. So all we're going to do now is it's going to be 1/2 times 2 to the 4th is 16 divided by 2 is going to be 8 minus 32/5. Distribute that 1/2 in there. I'm going to get 4 minus 16/5, which is 20/5 minus 16/5, which is going to give me 4/5. Moving on to number 4, this is just an evaluate an integral problem. So when I evaluate this integral, I'm looking at it, I can't integrate that as is. This looks like a U-sub problem, and I know what a lot of you are going to be thinking is, hey, the denominator there is 1 plus x to the 4th, let u be x to the 1/4. But the problem is you're going to end up with this x cubed, this or 4x cubed dx. And when we have an x on top, in that algebraic sub here, it's just going to get really, really nasty, and we don't want to do that. So I have to start thinking, wait a minute, maybe u isn't 1 plus x to the 4th. Maybe there's a more inner function there, which there is. Okay, this arc, arctan, arcsine, arcsecant, all of those other arcs that we have, those can get a little tricky, and that's what we have going on here. Because this kind of sort of looks like 1 over 1 plus x squared. It kind of sort of looks like that. So let's just let u equal x squared. Because I'm looking at this being written as x over 1 plus x squared squared. So when I do that, I'm going to get du to equal 2x dx. So I'm going to get half of du is x dx, which eliminates my numerator. I'm actually going to be good to go here. So I'm going to go ahead and rewrite this integral as the integral with a 1/2 in front, du on top, 1 plus u squared, which I know is going to turn into arctan. But the bounds have to change. So if I plug in a 1 for the top, I get 1. If I plug in a 0 for the bottom, I get 0. So we actually kind of get lucky here. The bounds do remain the same just by happenstance. So I'm going to get 1/2 arctan of u from 0 to 1. No need to change back into our bounds here, our x bounds. So if I plug this in, I'm going to get 1/2 times arctan of 1 minus arctan of 0. So it's important to know our arctan values. So I'm going to end up with, I don't mind, I'll put it right over here, 1/2 times arctan of 1 is pi over 4. And arctan of 0 is 0. So I'm going to end up with 1/2 times pi over 4, which is just pi over 8. Next one. This is one that gets a lot of people. I call these scary Riemann sums. It's really important to know these formulas. So for this one right here, I do know that my c sub k is always going to be a plus delta x times k. So I want to look for this whenever I'm trying to transform. And this is actually going to give you my integral from a to b of f of x dx. That's what the a represents. It represents the bottom bound. So I'm looking for this, and the change of x is always going to represent by b minus a over n. So I can clearly see that this right here is my c sub k. So because of that, I know my a value is 1. I know that my change in x is going to be 4 over n, which means that b has to be 4 larger than a, so b is 5. Okay, now what's my function? Well, let's rewrite this function again. So sine squared of, since I use this as my c sub k, I'm going to just write this as an x, and this plus 3 on the outside is just chilling, so we're getting an answer of b here. And what happens a lot, I see from a lot of people, is you're going to think that the a value is 3. It's not. Look for your a plus delta x over k, or sorry, times k, and that's going to help you a lot recognize these problems. So y'all just need to practice these types of problems a lot. This last problem here, this is actually a calculator problem. I just condensed everything, so you can go ahead and read through it. It's really just a prompt that says that Daryl wants to know how much water is in a lake. He's just trying to find the volume of this lake. He knows that the depth is 8 meters, and then this lake is the shape of 80 meters in length of its type of oval, and then he kind of measures around it. So using a trapezoidal Riemann sum, estimate the volume. So by the way, volume is going to be length times width times height, right? Length times width times height. Well, our height here on average is 8 of this lake, of the volume of the lake. So we're going to get 8. And then for the length times width part, we're going to do the integral from 0 to 80 of w of L. Let's write this as a function, w with the variable L. And we're going to use this part of the integral right here to estimate our area, essentially. So we're going to have our height is 8 times our area, so this integral is going to represent our area. So volume is going to equal 8 times this right here. So for the first trapezoid here, I have a width of 30. So I'm going to do 30 times the average of 2 plus 28. Okay? That 2 plus 28 comes right here. And then that width 30 comes from right there. So for the next one, I'm going to go from 30 to 40, which is 10 times the average of 28 and 42. Plus, now we have this right here, 40 and 50, which is going to be 10 times 1/2 of 42 plus 35. Plus, this width right here is going to be 30 times 1/2, let me write this down correctly, 1/2 of the average of 35 and 1. And then we can do all that calculations there. I trust that you can put this in the calculator correctly, and we're going to get an answer of 13,800, and this is going to give us meters cubed because this was in terms of meters. So our answer here is going to be C. And we covered a lot here in this video. Covered a lot of stuff, so hopefully you got something out of it, and don't forget to like and subscribe if you want to see more videos like this.